2013 question 16. Consider the following chemical equations. Which of the following is the correct combination of the reaction coefficients y and z? Now for these type of questions where they'll give you a chemical equation and they ask you to find the unknowns, there are three methods that you could do. Now each of these methods, they have their own strengths, and it would depend in each question which one you gotta apply. So I suggest you to learn all three of them. So it's a question of this year, 2013 question 16, and also you can try it on 2017 question 15. So another method is actually faster for that one. So in this video, I'll first teach you the quicker method for this question, but in 2017 question 15, there's another method that's faster. But I'll teach you all three here, and I'll just use one in the other video, or I'll see. So here, first up, for this question here, the fastest method would be to balance the two half equations that you see, and then overall find the overall equation. Now, what do I mean by the half equation? We learned that in book 2B, redox reactions. So in that chapter, we learned about the main characters. So who are the main characters here? That's this one over here, 2iO3 minus. Who's its partner in crime? It's obviously, you can see it has an I here. So the iodine on the reactant side would be its partner in crime. And who's the other main character? H2O2. And who's the side partner, or you could say his partner? It's O2 here. Then you're going to go ahead and take the main character. I'll do the pink one first. So 2iO3 minus, it forms I2. Now there are 4 steps of us to balance these half equations. The first step was to see whether the main characters are balanced or not. Here on the product side, I have 2 iodine. What I mean by 2 iodine, that means the iodine atom, there are 2 of them. Here, there are also 2. So that's perfectly balanced. The second step is to balance the number of oxygen atoms. Here, I have 3. No, you don't have 3. Remember, you need to times it by the coefficient. There are 6 oxygen atoms on my left side. This is oxygen atom. So to balance the number of oxygen atoms, I would add water on the other side, and I will add 6 water molecules. Okay, so the third step now is to balance the number of hydrogen atoms. So here I have 12 hydrogen atoms. How do I balance this? I balance it by adding hydrogen ions on the other side. Remember, it's not always that it's going to be on the left. It would depend on where you're starting the question from. So it can be either on your left that you're adding water, or either on your right that you're adding water. Look at the question every time. Now, final step, the fourth and final step is to balance the charges by adding electrons. So I'll need to see what are the overall charge on the left-hand side and the right-hand side. Left-hand side here, the overall charge for this is 2 negative. For this, remember, it's not just positive here. A lot of you just write positive, 1 positive. There are 12 hydrogen ions here. So it's 12 plus. Okay, so the overall charge on the left-hand side is 10 positive. How about on the right-hand side? Iodine is 0. There's no charge. Water, there's no charge on the top right here. You don't see anything there. It's also 0. So the overall charge here is 0. So how do I balance the left-hand side, right-hand side? Obviously, I need to add 10 electrons on the left-hand side in order to balance the charge number. So 10 negative here. Now 0 on the left, 0 on the right, perfectly balanced. Now after you're done balancing the first half equation, now you're going to go and grab the other 2 main characters, H2O2 to form O2. Now let's recall what were the steps, the 4 steps to balance the chemical equation. First step is to see whether our main characters are balanced. Now here, our main character is O2, H2O2, and you can see actually here it's already skipping steps, so let's just go to the second step, which is to balance oxygen. On the left-hand side, there are 2 oxygen. On the right-hand side, there are 2 balanced. So let's skip to our third step, which is to balance the number of hydrogen atoms. Left-hand side, there are 2 hydrogen atoms. So we learned that in order to balance the hydrogen atoms, I need to add hydrogen ions. Now, do you notice this time you're adding it to the right-hand side, and you add 2 hydrogen ions because there were 2 hydrogen atoms here. In the previous question, in the previous half equation, we added it to the left-hand side. So that's what I meant. Every time you got to look at the question. Final step, the fourth and final step, is to balance the charges by adding electrons. Left-hand side, overall charge, you don't see anything on the top right corner, so it's 0 for H2O2. Here, oxygen molecule is 0. but hydrogen ion, sorry, is 2 plus. So the overall charge on the right-hand side, 2 plus. Obviously, it's not matching right now, so I'm going to add electrons on this side, 2 of them, so that it becomes 2 negative, and this whole, on the right-hand side, everything, the whole charge is 0. So now that I've done writing the half equations, now our next job is to write the overall chemical equation. And for that, we have learned, in order to do that, we need to balance the number of electrons. So on the top here, I have 10 electrons. At the bottom here, I have 2. So the LCM, obviously, I know in order to balance them, I need to times this second equation by 5. Times it by 5, and then now you can write down the overall equation. So I'm going to grab everything that is on the left-hand side of the equation. So these are the two equations. You're going to combine them. Anything on the left-hand side, you're going to write them together. So 2I3 minus plus 12 hydrogen ion plus 10 electrons. And don't forget you have your 5H2O2. And then write your arrow. It forms iodine plus water. And here, obviously I didn't write the physical states because MC, don't waste your time on that. 10H plus 10 electrons. Okay, now obviously, if this was a normal long question in paper 1B, I would suggest you to make sure it's totally balanced. Left-hand side are 12 hydrogen ions, right-hand side are 10. That means here there are 2 hydrogen ions left. But anyway, we'll look at what the question is asking us. It's asking us to find Y and Z. Y is the coefficient for oxygen, which is 5. So immediately I can cross out A and D because Y is 5, 5. And then for Z, it's asking for water. Water is 6 here. 6. So the answer is C. Okay, doing this method would be the quickest way in this question. But you may say, sir, I don't really know how to, what are the main characters? How did you even know that it's these two and H2O2 and O2? What if I don't know? Okay, if you don't know, or for whatever reason you can't balance it properly, then I'll teach you the other two methods now. So first off, let me rub everything away from here. Okay. The second method that I'm going to teach you is basically you're going to substitute these values that you see here and put them into Y. So here, Y could be 4, Z could be 5. And what about X here? What about or W here? Now, obviously, you don't know what's W and X. So actually, you do know what is X if you think about it. Well, now, why do you know X? Here, on the right, let me start from the right-hand side. Right-hand side, do any of them have charges? You see iodine, there's no charge. Oxygen, there's no charge. Water, there's no charge. You don't see anything on the top right. So actually, the overall charge on the right-hand side is 0. How about on the left? Look at the left here. Here, I have 2iO3 minus. What's the overall charge? No, it's not just negative. Remember, there are 2 of them. There are 2 of... Actually, what does this 2iO3 mean? That means there are 2iO3 minus. There are 2 of them there. That's what it means. So here, obviously, you can see there are 2 charges. So I'm going to write here, it's 2 negative. And how about this one? This one, there's no charge, it's 0. How about here? Now here, this is where you can balance things out. On the right-hand side, the overall charge is 0. Here, you found that so far it's 2 negative. So what should be the charge for hydrogen ion here? Obviously, it's got to be 2 positive. Make sense? Now, if it's 2 negative, 2 positive, obviously now the left-hand side is 0. So actually, you do know what is hydrogen ion, which is 2 plus, 2H plus. Now you can find one by one, so after substituting all these 4, that Y is 4, Z is 5, and then one by one you can find it. Of course, this is going to take a long time. Now, but if you try this in another question, actually it would be faster. So we'll try it next time if we see a question. Now the third method, it requires a bit more math. Okay, now for this method, obviously right now I'm going to still use this, that we know the hydrogen ion is 2. Okay, and I just taught you why. So in order to do this third method, we first will check whether any of these unknown, can we figure them out just by looking at the chemical equation without any of this information that's provided here? Can we do that? yes, we can just do it for hydrogen ion. And the rest of them, it's kind of hard to do it unless you are given with some information. So this third method, what you're going to do is, so now that you know actually this is 2H plus, so what you're going to do here, actually I'm going to do it like this. Okay, so what's the number of hydrogen atoms? Number of hydrogen atoms. What I mean by that? Now look, over here in WH2O2, how many hydrogen atoms are there? So right now there are two. There are two. Here you can see there are two, but you'll need to times it by W. Times it by W. 2W. And here you can see that there are two also, because you can see there are two. Okay, this is on the left hand side. So the number of hydrogen atoms on the left hand, this is the left hand side, it would be equal to the number of hydrogen atoms that would be present on the right hand side. Does it make sense? Obviously, that's the whole point of balancing chemical equations. So here, there's no hydrogen here, there's hydrogen here. There are two of them, but remember it would depend on the coefficient. So let's say it's 2Z. Okay, now you're going to go ahead and, oh, by the way, actually, you've learned in math, actually, you can take the common factor out. So this becomes 2 times W plus 1 equal to 2Z. And when you move the 2 to the other side, basically you get W plus 1 is equal to Z. Okay, now you do the same thing for number of oxygen atoms now. Number of oxygen atoms. So the number of oxygen atoms now would be, on the left-hand side, first off, you have 2iO3. There are 6 oxygen atoms here. So I'm going to write 6. Plus, let's see any more on the left-hand side. Here, for WH2O2, I have 2. So you can do 2 times W. And no more. Okay, so this is on the left-hand side. And remember, it's going to be equal to whatever there is on the right-hand side. Right-hand side, how many do you have? Here, let me rub everything out. There is 2 times Y plus this one, O times Z. So O is just 1. So 1 times Z is just Z. Okay? Now this is the two equations that you have. Now you've learned in math that you can do the method of substitution. So what I'm going to do is I'm going to rewrite this W plus 1 equals Z. And I'll make W the subject of the formula. So W is equal to Z minus 1. And what you're going to do is you're going to grab this W equals Z minus 1 and substitute it inside W. So now you get a new equation. You get 6 plus 2 times by, now I'm going to put in my Z minus 1. Okay, which is Z minus 1, because I've substituted W as Z minus 1. And you'll get it equals to 2Y plus Z. And then what you're going to do is you're going to, one by one, substitute these values inside using your calculator. Okay, don't be smart and just use your, fingers or something. Use a calculator.